It doesn't have a pre-lab, but from here on out they all have pre-labs, because what that means is from here on out it's going to be Verilog, and you don't want to wait till you get to lab to do the Verilog. So even if you don't have Vivato, and if you don't try it out some other way, at least type it into a text document, and like have at least your first try ready to go before you get into lab. And I'll explain more about that later.
Because if it's wrong, you can just like make minor adjustments. But if you haven't started on it,
If you haven't started on it, you won't finish.
yeah, you're likely not.
You might finish for the lab tomorrow, but from here on out, it's going to be more than you could do in one lab. Okay, so let's take a look at the lab for tomorrow and see what it is. And this is, by the way, as far as I know, the first time he's done this lab. So, am I recording? Yes. All right. So let's take a look at it. And this is not where I meant to go. Okay, so the first thing it says to do is to, using Vivato to program the Basis 3 board, give step-by-step instructions to implement functions on the Basis 3 board, and it's just saying do what's in that document, and if the document hasn't changed, it's the same as last semester, and you probably did it last semester, so the first part should be easy, but let's take a look and see if it is the same as what y'all did before. But it's step by step, and so there's nothing to this one. You don't need me for this to read out the steps to you. You just follow them.
Can you do it anyway?
Well, we're going to do some of it anyway. Okay, so it tells you, how to start Vivato, how to do a new project, the settings that you need to use to get the right settings for the basis board, how to add a source, and then I think this is the same as the one that was in there last year. And so you do that, and then you do the constraints, and then it shows how to do a test bench, which we're going to talk about a little bit because you might find test benches more useful this year than in the past. Hold on a second.
You might actually still have an incorrect truth taking.
Okay, so I am going to take a number, 526, and I am going to subtract the number 259. And you have to go back to second grade and remember what you did. And depending on when you were in second grade, at different decades, yes, did you not do second grade?
Oh no, I was gonna be like, oh, in second grade, we took the 6 and made it 16.
Yeah. You got it. That's right. But I was going to say, depending on when you were in second grade, they always give new names to these, like regrouping, or in my day it was borrowing, and then they have they have something new that they're doing now. And anyway, so but borrow. Everybody says borrow. So yeah, but you are correct. So tell me what you said.
You would take the 6
Uh-huh.
and make it 16, and take the 2 and make it 1. You're carrying the borrowing from the 2.
Right, because in 526, what place is the two? What place? It's in the tens place. So I'm taking 10 away from the 20 that's there. So this is 500 plus 20 plus 6. I'm just rewriting it as 500 plus 10 plus 16. And then I'm using that 16, and I subtract 9 from 16, and I think I get 7. All right, and so now I need to subtract I need to subtract this 50 from 10. So I need to subtract the 5 from the 1. So I do the same thing. I take 1 away from that 5, and I make this 11, and 11 and subtract 5 is 6. And then I can do 4 subtract 2, and I get 2. So now I want to think about if I had this 526 minus x 4x, and you had to do the subtraction for the middle column, and what would you need to know before you could do the subtraction for that middle column?
The placement of the middle column. Okay.
Yeah, yes. I'm looking for something else a little bit. Yes?
You need to know if you need to give over to the 6.
I need to know if I had to give over to the 6 or not. Right. I can figure out at this point, I can figure out that I'm going to need to take from the 5.
Yeah.
I have enough information to figure that out. What I need to be told is, did I already give away to the 6? Because I need to know, am I going to do 12 subtract 4 or am I going to do 11 subtract 4? And that's going to depend on whether or not I had to lend to the 6. Okay, well now let's look at a binary number. So 1, 0, 0, 1, 0, subtract 0, 1, 0, 1, 1. Okay, so I'm going to do this the same way we did this with our base 10. So I want to subtract 1 from 0, but I can't do that. So what do I need to do? I'm going to borrow. Now, am I borrowing? What am I borrowing?
You're borrowing to the second, to the one that's farthest to the left. Because there's two.
Well, I've got a 1 right there.
Oh.
So I'm going to borrow from this one.
Yeah.
But my question is, what have I borrowed?
You borrowed 2.
I've borrowed a 2. And so this then becomes a 10 or a 1, 0, just like it would in decimal. So it doesn't become a 1. We're used to thinking, okay, well, I'm borrowing a 1, so it'd be a 1. It doesn't. It's a 2. Because this is the next, these are powers of 2. So when you borrow something, you're borrowing a 2. So this is 1, 0, subtract 1. So what is 1, 0, subtract 1? 1. And then this became a 0. Okay, now we're at what you were saying. So I want to, now I have 0 subtract 1, but this doesn't have anything for me to borrow from, this doesn't have anything for me to borrow from, have to borrow from this, so this becomes 0, this becomes 1, 0. And then when I borrow from the 1, 0, that would become a 1, and this will become a 1, 0. And when I borrow from this 1, 0, that becomes a 1, and this becomes a 1, 0. So now I have 1, 0, subtract 1, so that's 2 minus 1 is 1. And then I have 1 minus 0 is 1. 1 minus 1 is 0. So 0, 0. Now if this is right, 0, 0, 1, 1, 1 plus 0, 1, 0, 1, 1. That's 0, carry the 1, 1, carry the 1, 0, carry the 1, 0, carry the 1, 1. Yep, it works. Those are the same.
We just added.
I just added back. This was my check. Remember back when you were in like junior high and like taking algebra 1 where you had to check your work and you had to plug it back into the equation and show you, it was infuriating. So that's what I just did there. Okay, so now let's go back and look at this and see if this makes sense and if we can determine what these variables mean. Borrow too low and borrow from high. So borrow too low means, so I am subtracting, I've got my inputs are U, V, and borrow too low. I would have called this lent too low. Like you actually needed to know whether you lended it or not. Like, because you're not. This one is not. Did you borrow? This one is did you already lend one? And so if I take u minus v, and then I have this other one that says whether or not I loaned something out. So if I had 0 minus 0 and my borrow to low was 0, what would I expect my result to be? 0. What if I had 1 minus 0 and my borrow to low was 1? No,
It would be 0.
it'd be 0 because what this is saying is I loaned this away.
Oh.
Okay, so let's look and see if I'm understanding the chart right. So if I had 1 and 0, this is this row right here. This row right here. 1 minus 0, but my borrow to low was 1, then my difference should be 0.
Oh, because it would have been 1, but because you borrowed it. Okay.
Yeah, let's do 0 minus 0, 0 minus 1, 1 minus 0, and 1 minus 1 with borrow to low equaling 0. Okay, so it doesn't mean that you might have to borrow yourself. That's why I would have called this lent to low. This is just saying, did you lend it? So if my borrow to low is 0, so I did not give anything away to the thing to my right. So what's 0 minus 0? That'd be 0. Now, you can borrow if you need to. So what's 0 minus 1?
0. But, I mean, you could borrow 1.
You can borrow, so you would borrow a 1, and then you would have 1 0 minus 1.
That's fine.
That'd be 1.
I thought about, I don't know why, but I thought about canceling the 0 out and giving them 1. That would be 1 minus 1 would be 0.
That's what I did, like, for half of my drive over here, and I was like, why can't I match his truth table? I'm not going to be able to explain this. And then suddenly it clicked, yeah. Okay, so what about 1 minus 0? 1, and 1 minus 1? 0, all right? Now, for any of these, would borrow from high, what would borrow from high be? Did we borrow from high for this first one?
No.
For the second one?
Yes.
Yes. The third one?
No.
No. The fourth one?
No.
No. Okay, so now let's do the same 4 subtractions. Where borrow to low equals 1. So this means we loaned something to the low. Okay, so if we loaned something to the low and we're at 0 minus 0, what must we have already have done? Like, how can I, if I'm at 0 minus 0, and I'm saying I loaned something to the thing to my right,
It's already.
So it would have been 1? No.
So this means that
You steal 1 and then you give 1 away.
no, so it is 0, so it's like I had before. It's like I'm taking this and I'm just giving you this out of context. You don't know what's on either side. So you don't know that, but this is my original problem. The only other thing you know is, hey, when I did the one before you, you had borrowed. I must have borrowed previously before. I must have been a 1 0. And then after I loaned what, after I loaned, then what was I?
So this is,
You're a one after that.
I was a 1.
yeah,
You were a one or you are a one?
I'm now a 1. Yes. So what this is what we have. We know that you had loaned this way.
yeah.
So in order to have done that, you had to have borrowed yourself. And then, once you did that, you would be a 1. And then what's 1 minus 0? 1. Now let's see if that's right. So that was 0 minus 0, borrow to low is 1, and the difference is 1. Now, what would our borrow from high be here? It would be 1 because we know we had to borrow from high. Because we had to do that to get that first 1, 0. Okay, so the borrow from high would be 1. Okay, now if I had 0 minus 1, and we know that we had loaned. So that means that we were like this.
So that you're saying like you had to borrow one from the higher one and then you also had to give up one to the next one? Is that what that is saying?
Yes.
Okay.
I'm saying I'm told that I had to give one to the next one, and I know that in order to do that, I had to have borrowed one. So that gives me 1 minus 1 is 0. That's my difference. Did I borrow from high?
Yes.
Yes. So borrow from high is 1.
Borrow from high,
It's an output.
yeah, so that means like, you said that it means both you gave up one and you borrowed one? Okay, so it's only you borrowed one from the next one.
Yes, but in this instance, the
Because
reason we
0.
know we borrowed one is because I can do 0 minus 0 if I hadn't given one away. So 0 minus 0, if borrow from low is 0, is just 0, and that's why we have to have that extra piece of information.
What we did previously with the other numbers.
Well, that's why you have 3 inputs. You have U, V, and borrow from low. Because that tells you whether or not you have already borrowed or not. Or if you have already loaned or not. So now if I have 1 minus 0 and borrow from low equals 1, that means I loaned this 1 to the one to my right, and the one to my right became 1, 0, but I don't care about that. Did I have to borrow before in order to be able to loan? No.
Okay, that makes sense then.
Okay. So what is my borrow from high?
Zero.
Borrow from high is 0.
So you're just basically just showing us how this truth table is like being made.
Yes?
Okay. So let's
Okay. And then 1 minus 1, if we have borrow from low is 0. Is 1. Borrow from low is 1. Then that means that we loaned this. And we have a 0.
So is borrow from high secondary or like in sequence? It would be after the borrow.
It just means, did you have to borrow from high in order to do this subtraction? And so in order to do this subtraction, will I have to at any point borrow from high? I will have to now to do the subtraction. And so now I have 1, 0 minus 1, which is 1, and borrow from high is 1. Okay, now some of you at this point will be mad because I'll say you don't really have to understand this, but you probably do, because it may show up on a test, or there may be a question about it somewhere. And so just saying that you could write the program without understanding any of this is the way to get a D in a class, and not the way to get an A in a class. So understanding everything is really key here. All right, so, but what do we need to be able to write this function? All we really need are these things right here. We don't even need the truth table. The truth table comes from this. So let's see how to write this. What time is it? We have lots of time. Okay, so I'll do it in Verilog. I'll do it in Viveda. Okay, I will go ahead and show you what I was going to show you. Maybe I'll do it in both. There's a place called, yes.
I'm sorry, I just getting a little confused, but so I'm saying you're explaining the truth table when we're gonna get a one versus a zero, when adding the two bits together or subtracting them. But so are we going to know sort of like is the code? Are we gonna know going into each execution of the code if there is like a bit on the left or a bit on the right that's going to be borrowing a one?
Okay,
So,
well,
like I'm just not understanding how this is all working.
okay, so let's look at the inputs and the outputs, and we'll see how it works. And it's also going to come up in the example I'm going to do with y'all, so you'll see how it works with that as well. So if you look at the lab tells you that your inputs are U, V, and borrow to low. So your inputs are your 2 digits and whether you borrowed or not.
Right?
And your output is your difference and whether you needed to borrow. So it's exactly what we just did. But you don't even have to know that because he's given you the functions that give you that answer. So these functions take the 0 and the 1 and whether you borrowed to 1 and give you the difference and the borrow from high. And so what you will be told, I assume, is U equals 1, V equals 0, borrow from low equals 0, show me what you get. Which is why I'm saying you don't really have to understand it, because if you just put this in, it should work. But that's where it's coming from. So the borrow from low is telling you that you don't have to know what was next door to you, but you know that you loaned one to them.
Alright, so this is basically a slice of a code where we would in parallel decide like a bit of information about the two numbers being added in binary, if there's carry in and carry out, and then we would take that information and use it to run this code, which tells us what the result would be.
Yes, so what you would do is what we're going to do, is you're going to feed it your initial one. So your initial one would be like a 0 and a 1, and your borrow from low for your first column is always going to be 0. And then that is going to give it to the next one, which is going to give it to the next one, is going to give it to the next one if you set up your function right. But you don't even have to do that for your code for lab, but you will have to do it for code later on, so we're going to practice it.
Alright.
Is that?
Yeah, it makes sense.
Okay.
This is like I think a vertical slice is the word.
I'm not sure what kind of slice it is, but yes, it's a slice. It's a slice. So we're making the function that you can put together to make an n-bit subtractor. So we're making a full subtractor which subtracts 1 column. But if I use 5 of those, I can now subtract a 5-bit number. Okay. So where was I? Oh, I was showing you this site right here, which is EDA Playground. It will allow you to, you can write your Verilog here, and you can test it here with a test bench, which we may or may not get to today. I hope we do. Actually, I think what I would like to do now is I'd like to take a quick little break where I load up some code and then we talk about it and we see how it works. So I'll just take a little break while I get what I want to do and show y'all. And so maybe like 5 minutes.
It's not getting
Okay.
input in here.
I'm back. I'm going to do a little bit first. So this is the website that I was telling you
Do you
about.
wanna unpause the?
I think I did. Did I?
Oh, okay.
I did. So this is the website I was telling you about, EDA Playground. If you make an account here, you have to use your LSU address. And so here, this is the first part of y'all's lab that you have to do. This is the code that they give you. And this is the test bench from the document that's in the handout. And so what this is supposed to do is you have inputs A, B, and C, and you have output D, and you have output reg E, and you assign D equals to, this is also just right in the, this is right from the using programming the board.
Is it the Bravado introduction?
Yes, it is. It is. And so assign D equals A and B, and then always at A, B, and C. If A equals 1, E equals B, and this little symbol, the caret, is exclusive or C, else E equals B or C, that's the single line. So I want to explain a little bit about the test bench over here. Anything that's an input in your main, you make as a reg in your test bench. Anything that is an output, you make as a wire. And then when it's time to put what you want to test, you put the name of your your regular function, the name of the function you have over here, you put right here, and then you give it a test name. UUT stands for unit under test. You can call it whatever you want. And you have the variables here. I make them the same order as the ones over here, so I don't have to worry about it. There's some notes here on what to do if you want to change the order. And then what this test bench does is it runs through all the possible values of A, B, and C. So A, B, and C being 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and so forth. And then it displays them here so you can check and see if you got the right values.
So on the PDF, on the documentation,
Yeah.
the values for 6 and 7 for like on the handout.
Are they?
Mhm.
Huh. Are they right on mine? 6 and 7?
I think so.
Yeah. Okay. That's interesting. Huh. Okay. All right. So now what we want to do is talk about how you're going to code your full subtractor. And if I am understanding correctly, it looks like he wants you to have separate functions for the difference and for the borrow from high. Can y'all tell me whether you think that's correct or not? All right, so I'm going to call this Lab 4. Is it Lab 4? Spring 2025. And RTL project. And family Arctic 7. Package 236. Speed -1. And it's this middle one here. That's all in your handout. And then finish. And we're going to do the same thing that you would do with the subtractor, but we're going to do an adder. Okay, so we'll make a new design source. And then y'all are going to help me here. Create file. What shall I call it? Full adder?
Lab 4.
Lab 4. Lab 4. Spring 2025. Okay,
Make good documentation, you know?
finish. Okay, yes. All right, so somebody look at the lab and tell me what my inputs and outputs are.
Your inputs for U will be,
Just,
you want me to do U and V or?
yeah, I just need the names of them. UV,
UV, B, what is B, B2 low?
yeah, I'll just call it, I'm
Did
gonna
you
call it
mean
BTL.
Did you mean to put two,
I did not, thank you. And my outputs are different,
Outputs is difference bit, and then B from high,
borrow from high. And right now, we have these just as single bits, and so we could do them as vectored signals if we wanted to. And if we have time, we won't have time. Okay, so input except here, I'm not doing the subtracting, I'm doing the carry. So I'm gonna have see, carry from low and carry to high. So that's like carry in and carry out, but I'm just trying to use the same sort of logic that we had. So carry from low or carry to high. So if I'm adding 2 bits, what information do I need to be given? Which of these is going to be the input and which of these is going to be the output? Carry from low or carry to high? Carry from low is going to be my input. And then my output is going to be sum, which I need to put in here, so that's equivalent to your difference, sum, and carry to high. Okay, but now I'm going to, if I understood correctly, we're supposed to have these functions. What the first function is supposed to be difference, so I'll have it as sum, and sum would be sum is going to have U, V, carry from low, and my output is going to be sum. I'll call this summation, so I don't have the same thing there. My output will be sum. And I'll come and fill in stuff in a minute. And then I have to have a module that's going to get me my carry out. So my module, I'll call it carry out, is going to have U, V, carry from low, and the output is going to be carry to high. Okay, so then what I want to do is, so this input U, V, carry from low, output sum. All right, so now what I'm going to do is you have the formulas, the functions given to you on your lab handout. I went to your textbook to get the functions for the sum and the carry out. So let's see what they are. I'm doing a full adder just like y'all are doing a full subtractor, and I want this one. So the sum is x exclusive or y exclusive or cn. So my sum equals u exclusive or v exclusive or CFL, semicolon. Oh, assign. All right, and then my carry out is all of this business, which I won't be able to remember. And now I just need to change these names. And assign. All right, so now what do I do? So I have these functions to get the sum and the carry out, but it's not really my adder. So what's that? I have to do like I have to use those modules that I made. So I can just say here summation u comma v comma carry from low comma sum, and I can do, what did I call the other one? Carry out u comma v comma carry from low comma carry to high. And that would do it. And so then, as long as I made my constraints, see what time it is. Yeah. Let's see what the constraints would be. So let's make the constraints.
Is there gonna be a reference that we look at while we're in the lab?
Right.
Okay, cool.
A reference.
Never mind.
Well, like using Bravado, the thing, well, what's connected to it?
Oh, let me get y'all. Do y'all not have like? Let me see.
Because
It
I'm not
says,
gonna remember.
it says a lab 4 assignment, and then above that says using Bravado to program the basic tool board,
Yeah.
and that has like
Right, so what that has on it, where was I on that?
I still have your constraints file from the semester.
Which constraints file?
Yours.
Oh yeah, that's the one to use. I mean, that's, let's see if there's one here. So what's in that file that's in the website is the first part that you have to do. So the first part that you have to do is right here. And it's all there. So it's all, oh, I think I downloaded this already. I think I showed you all. So the first part that you have to do is it's all the reference for setting it up, all the stuff I went through, and then here's the program that you need to do, and then it even shows you the constraints. You got those right there. So so those are some constraints, and then if you have, let's see if he has a sample constraints in lab resources. No, so let me show you all the sample constraints, and I will put it in SI resources. So let me show you what you need for that. What was last semester? 2024 fall. That's not it.
So that function we just put into your simulator is the same function that's going to be able to use for the lab?
No,
It's different.
it's different.
But I'm saying
How is it
so,
different? What do you need to do that's different?
This is
So what did I do? What was the name of my program?
Oh.
It was an adder. What are y'all doing?
subtraction.
Now, where did I get my functions from?
From the book.
From the book. Where are you going to get your functions from?
From the book.
No, they're right there. They're given to you. They're right on the handout. So where I did the carry. So where I did a summation and a carry out. Y'all have to do a difference and a carry to high. Or so if you just look at your lab, it's all right there. It's so it's almost identical. I have a hard time like not making them identical. It's like this is really close to identical, but not. Okay, so what's different? What's different? Rather than having summation and carry out, you have diff and b from high. And where do you get your functions? They're right here. They're just already there. So you just copy them from there. And that's it. And that's it. What was I in the middle of doing? Oh, constraints. So, so I have this file that has, those are the wrong constraints, that has like the constraints that you might want for anything. So it has but they're all commented out, except they're not, so I need to make sure that I comment them out before I post it. And so what you would do is you would take this constraint file and just choose the ones that you need for each lab. Where's comment on this? So like for instance, you can just choose from this whichever switches you want and whichever LEDs you want. So what switches do you want to use for our example? Does it tell you, do you have particular switches that you need to use for yours? All right, so I will just take the first three. So I'm just going to grab the first three and I'll put them in Vivado in a constraints file. I'm going to put it in SI resources. Lab for constraints. So I have to give them the right names. So one switch will be U. Another switch will be V. And the last switch will be whatever I called, what did I call it? Carry from low. And then I need to get 2 LEDs. So I'll just get the first 2. And so where I'm calling these sum and so I'm calling it sum and carry to high, you would call difference, and borrow from high, or yeah.
Do we have to put borrow from high before we put the initials?
Do you have to do what?
Do we have to put borrow from high there before we put the initials?
I've never heard them complain about variable names.
Okay.
Okay, so let's see what happens if I open an elaborated design.
Because I never got it to work. Everything did.
Go on the website. It's like super.
That's the reason why I downloaded the too.
Just keep in mind, I always have at least one of my 2 laptops, often both, that have Vivado on them, and I've got a desktop in my office that has Vivado that you're always welcome to come in and use. And I have at least 1, sometimes 2 basis boards, so you can always try things out. You just need to make an appointment or let me know. I may or may not be there, but it'll work. So let's see. I like that. So this is what it looks like. And if I want to see what's going on inside this, it's showing, if you remember, my first one was 2 exclusive ORs and my second one was some other stuff. So that seems to work. And then I could compile it and load it to the thing. So let's see. Yeah, I don't have time to show you how we would change this with vectored signals, but I may make a video on it and show you how you would use this to actually add together like 2 3-bit numbers. Like this is just or subtract. You know, this is just making, like you said, a slice. It's just a slice of it. You know, how would you actually use it to subtract two complete numbers? Let me get that text file for you with the constraints, and in case you didn't hear about it last semester, I really like, as do a lot of people, this program called Notepad++. So if you can't download Vivedo for all kinds of reasons, either you have a Mac or your computer doesn't have an extra terabyte of space, or you don't have an extra year to wait for it to download or whatever, this is a nice little editor that you can tell it that you're using Verilog, and so it will catch syntax mistakes for you. And so you can't run it, it doesn't compile, but it will catch, you know, some things for you. So I am going to, did anybody in here use this last semester? Yeah. Does anyone remember where the comment thing is? Okay. Well, I'm going to comment out the things that need to be commented, and then I'll put this in the SI resources. Any questions before we go? Do y'all feel like you know what to do?
When you say comment out, like the little number symbols?
Yes, I just want to do it automatically. Like I want to highlight, because I have, none of my LEDs are commented, and I don't want to put the hashtag in on, or a number symbol on each one. And there's usually something to do that. But okay, well, I'm going to stop this recording and upload it. And I may be posting